Smooth classical physics is an optical illusion. Okay, let's just pause and really think about that for a second. It sounds completely like science fiction, doesn't it? But today, we're actually going to mathematically reverse engineer exactly how we arrive at this totally mind-bending conclusion. Welcome to This Explainer. We are going on a seriously fascinating mathematical journey today. We're going to trace the exact steps, literally from the failure of a major algebraic conjecture all the way to the birth of macroscopic gravity. We'll be closely following the source equations to see how pure math actually builds the reality around us. So, here is our game plan for today. We'll start with a pure algebra boundary, move into forcing a quantum collapse, check out the Adelic Langlands liftoff, dive into explicit Whittaker functions, look at the uninvertible singularity, and finally wrap up with emergent macroscopic spacetime. All right, let's jump right into section 1, the pure algebra boundary, the n greater than or equal to 3 anomaly. This right here is our very first domino. If you look at dimensions n equals 1 and n equals 2, the Jacobian conjecture holds perfectly true. But the moment you jump to n being greater than or equal to 3, it completely falls apart. The critical anomaly we really need to focus on is a real, constant Jacobian determinant equal to -2. Now, this -2 might seem simple, but it's actually hiding a massive 3-to-1 global topological branch sheet. Literally, this is the seed of everything that follows. As long as you've got Newton polygon edge rigidity, or maybe strict orthogonal symmetry, the famous Dixmier conjecture completely survives. But notice what happens if you have an unconstrained rank n greater than or equal to 2. Yeah, it completely fails. The Alpöge lift just effortlessly bypasses those rigid boundaries using non-abelian monodromy, and that drives this absolutely catastrophic 3-to-1 operator collapse. Moving right along to section 2, forcing a quantum collapse, the BK reduction. Okay, so we know pure algebra fails at this boundary, right? Let's look at how that failure fundamentally breaks down quantum space itself. This brings us straight to the BKK reduction sequence equations. Take a look at the BCW linearization, where g of x equals x plus h of x. This map explodes into a massive 24-variable polynomial map, where h of x is strictly cubic homogeneous. Honestly, this is the absolute foundation of the complex geometry we are about to untangle. Let's break this sequence down a bit. In step 1, we linearize, simple enough. But step 2, symplectization, that is where the math really shifts gears. The cotangent lift basically creates a 48-dimensional non-invertible symplectomorphism. Try saying that 3 times fast. Then, by step 3, our standard commuting variables are transformed directly into quantum generators through a central reduction to the 24th Weyl algebra. Now, we really need to pay attention to the invertibility failure happening here. We've got structural preservation on one side. The strict symplectic lift perfectly preserves commutation invariance, meaning the commutators of AI and AJ equal 0. But on the other side, because of that 3-to-1 spatial folding we talked about a minute ago, a quantum collapse is practically forced. The operators AI simply cannot uniquely reconstruct the universal base fields. It's like a broken mirror. The canonical lowercase AI cannot be written as finite polynomial combinations of our transformed operators. So, what's the big takeaway? It's all about this contrast. Normally, in a standard quantum framework, you'd follow a canonical path, giving you this nice, smooth, continuous space that you can easily invert. But the Alpöge anomaly? It traps us entirely in the collapsed quantum path. What should absolutely be a smooth path in quantum space is now being generated by structurally distinct algebraic operators. It is fundamentally fractured. Which brings us to section 3, the Adelic Langlands liftoff, shifting the framework. To actually resolve this huge fracture, we have to make a massive mathematical leap out of standard complex geometry and lift right off into the vast number-theoretic ring of Adels. So let's look at the mechanics of that lift. The top equation is showing our degree 7 map lifting from the complex numbers straight into the Adels, which we denote as a sub q. Remember that constant Jacobian determinant of -2 from earlier? Well, right here, it actually guarantees perfectly flat, unramified data structures for all primes p that do not equal 2. After that, the static isomorphism grabs our 3D Galat representation and maps it directly to a cuspidal automorphic representation of GL3. And finally, a Fourier-Mukai transform steps in to model this uninvertible collision as a non-trivial algebraic twist, leaving us with a 3-sheeted multiverse. Mind-blowing stuff, right? And this actually beautifully categorizes exactly what happens to our local unramified primes once they are inside this Adelic space. Basically, they fall into three very distinct S3 monodermy cycle states. The split identity gives us constructive coherence. The transposition creates phase rotation. But, and this is the wild part, look at the inert 3 cycle at the bottom. It results in a primary operator action of absolute zero, literally complete destructive erasure. It's a perfect example of pure math directly dictating physical behavior. All right, Section 4, explicit Whittaker functions. Explicit wave functions. So knowing how the primes split, that's really only half the battle. Now we actually need the real wave functions that govern these spaces. Here's the master equation for the unramified Whittaker functions. I know, it looks super intimidating, but let's break it down together. We are essentially evaluating W sub p of g. The math here inherently fractures into 3 completely distinct evaluation branches, and that's based entirely on the Satake parameters we were just looking at. So the 1-1-1 split, the 1-1-1 transposition, and the 1 omega squared inert evaluation. Let's put all those complex formulas into plain English for a second. The split evaluation, that yields zero distortion. It's just mathematically flat. The transposition evaluation introduces a parity-dependent geometric twist, which essentially means space itself literally oscillates. And then the inert evaluation acts as a strict periodic modulus screening, basically hiding data entirely based on cyclic permutations. So looking at what these Whittaker functions actually do to physical space, in domain I, the split primes leave space looking exactly like standard classical flat spacetime, but check out domain 2. You get this crazy sign alternating deformation, just rapid positive and negative phase oscillation. And in domain 3, the inert primes create a full 120-degree chiral erasure. The continuous complex rotation cancels out globally, which literally hides this entire dimension from any sort of macroscopic observation. Let's head into Section 5, the uninvertible singularity, the ramified core. Okay, we've successfully mapped the smooth parts of our Adelic space. Now we need to move to where things get, well, absolutely not smooth. The ramified core at p equals 2. Why p equals 2? Well, because our original Jacobian determinant anomaly was exactly -2. That specifically forces all of the wild ramification strictly into the prime 2. When we take that and integrate the core volume over the minimal paraharic congruent subgroup, gamma 0 of 2, the math spits out a very specific, undeniable result. So what is the crucial so what here? The answer is exactly 1/7. Exactly 1/7 of the local operator space at p equals 2 is entirely consumed by the nonlinear coupling of these topological sheets. And guys, this isn't just some random fraction we pulled out of thin air. This exact mathematical limitation in pure algebra establishes a precise calculable physical mass gap. This singularity isn't infinite at all. It is precisely 1/7 of the local space. And finally, Section 6, emergent macroscopic spacetime, the grand finale. So we have our algebraic anomaly, we have our Adelic wave functions, and we have our mass gap. Let's bring all these equations together for the big picture. This right here is the master equation of Lagos field theory. Z represents the infinite product measure across all the Adels. And just notice how it beautifully, perfectly marries 2 completely different worlds. You have the standard Archimedean classical action, the continuous physics we're all used to. But it is being directly multiplied by the product of W sub p, which are the local topological weights imported directly from our unramified Whittaker values, the 1, the -1, and the omega. And this is the ultimate result. When you run all the possible quantum paths through this Adelic action function, domains 2 and 3 completely disrupt any smooth motion. The rapid, destructive sign flipping creates heavy interference friction, and that systematically straightens out those erratic nonlinear curves. Plus, the chiral lattice trapping at 120 degrees perfectly cancels out smooth motion. So what is actually left over? Uniform velocity parallelism from domain I. Gravitational geodesics are exactly and literally only the constructive residue that survives this massive non-abelian S3 Adelic filter. Smooth classical physics truly, literally, is an optical illusion created entirely by mathematical cancellation. We have just traced an incredibly mathematically rigorous path, proving exactly how a simple algebraic failure scales all the way up to create the very fabric of gravity. And it leaves us with a truly provocative final thought. If the fundamental force that holds entire stars together is literally just a structural residue of a collapsed polynomial map, What other massive physical realities are currently just hiding out there in the unresolved anomalies of pure math?